Okay, welcome to part 2 of the Bernoulli trials videos. This is going to focus on questions that have at least and at most in them. So let's have a look at our example. So an at least question. A survey shows that 60% of the population of a town are female. If 7 people walk past a point in the town, what's the probability that at least 3 of them are male? Okay, so this is an at least question. So we need to have a look at what that means. Well, at least 3 of them are male means we could have 3 males, we could have 4 males, we could have 5 males, we could have 6 males, or we could have 7 males. But we can't have, I'm just going to draw a line here, we can't have 2 males, 1 male, or no males. We can't have either of them. So this is not this many. We can't have this, but we can have this. So I want to look at them and see which one of them is easier to calculate. Well, it's easier to calculate 3 things than it is to calculate 5 things. So we can calculate these 3 things, the probability of having no males, 1 male, or 2 males. And what we can do is we can do 1 minus this probability, 1 minus the probability of not 1, 2, or 0. And that will give us then, that will be equal to this probability here. Okay, so I'm going to do 1 minus the probability of no males plus the probability of 1 male plus the probability of 2 males. And that is equal to this probability here, the probability that at least 3 of them are male. Okay, so let's take each of these individually. Now this is going to be a Bernoulli trial. The first one is straightforward. The probability that none of them are male, well, that is going to be the probability that they're all female. So 60% of the population are female. So the probability of a female walking by is 0.6. And how many people? It's 7. So that's 0.6 to the power of 7. Now, I don't need to do anything else with that. I would technically say it's 0.4 to the power of 0. And it would be 7 choose 0, which is just 1. So that would be multiplied by 1 here and 1 here. So I don't need to do that. But I will then have a look at this one, the probability of getting 1 male. Okay, so the probability of getting 1 male. The probability of a male is 0.4. How many males do I want? I want 1. The probability of a female is 0.6. How many females do I want? I want 6. And then we need to multiply this by how many ways can this happen? This can happen 7 choose 1 ways. So I have 7 choose 1 times 0.4 to the power 1 times 0.6 to the power of 6. And then that's going to be added to the probability of 2 males. So let's do that one. The probability of a male is 0.4. How many males do I want? I want 2 males. The probability of a female is 0.6. How many of them do I want? I want 4. And how many ways can this happen? This can happen 7 choose 2 ways. And remember then, this whole thing is going to be in brackets, and it's 1 minus that. Now, you can do this in your calculator all in one go, or you could calculate them individually. I would prefer to do it all in one go, so that's the way I'm going to do it here. So it's 1 minus first bracket, okay, and then the next bracket is 0.6 close bracket to the power of 7 plus bracket 7 choose 1 close bracket times 0.4 to the power of 1, so I don't need to put that power in, times 0.6, that's to the power of 6, plus bracket 7, choose 2 times 0.4, close bracket, squared. Next bracket is 0.6, and that's to the power of 4. And then don't forget to close your last bracket at the end. So if you follow all of these inputs here with the brackets that I have, you should be fine and it should work, and you should get an answer of 0.4059. So that's equal to 0.4059, which is approximately equal to 40.59%. So the probability of at least 3 males walking by is 40.59%. Now let's have a look at an at most question. So an at most question is here. A biased coin has a 58% chance of landing on heads. If it is tossed 10 times, find the probabilities of, okay, so we have 2. 1, landing on heads at most twice, and landing on heads at most 8 times. Okay, so let's have a look at most twice. At most twice means we can have 0, 1, or 2. Okay, we can't have 3, 4, 5, 6, 7, 8, 9, or 10. So it should be clear that I'm just going to calculate the 3 of these probabilities here and add them together. Okay, so the probability of no heads, so that means I'm going to get 10 tails. So the probability of tails, let's take these individually, the probability of tails is 1 minus 0.58, so that's 0.42, and I want 10 of them, so that's to the power of 10. Then I'm going to add on this one, so the probability of getting 1 heads. So the probability of heads is 0.58, that's to the power of 1. The probability of tails then is 0.42, that's to the power of 9 because I want 9 tails. And then how many ways can this happen? This can happen 10 choose 1 ways, which is just 10 ways. And then I'm going to add that again to the probability of getting 2 heads. So it's going to be similar to this one here. The probability of getting heads is 0.58. How many heads do I want? I want 2. The probability of tails is 0.42. How many tails do I want? I want 8 tails. And then how many ways can this happen? This can happen 10 choose 2 ways. Okay, and then I add the 3 of these together to get my final solution. So we can do that into the calculator in one go again. So in one go we have 0.42 to the power of 10 plus 10 choose 1. Now I know that's just 10, but I'm just going to put it in as it is on the page, times 0.58, that's to the power of 1, times 0.42, that's to the power of 9. And now I'm going to add on 10 choose 2, that's times 0.58 to the power of 2, and then that's times 0.42 to the power of 8, to the power of 8. So that's equal to 0.0171, rounded there to 5 decimal places, 19. So that's approximately equal to 1.719%. Okay, so flipping the coin 10 times, the probability of getting at most 2 heads is 1.719%. Now the second bit, what's the probability of landing on heads at most 8 times. So at most 8 times would either be 0 times, once, twice, 3 times, 4 times, 6 times, 7 times, or 8 times. Okay, well look, we already have 3 of them done. I'd have to do that 8 times in order to calculate that. Or I could do similar to what I did in the last question. I could do the calculation for 9 times or 10 times, and I could do 1 minus the probability of this. So that's what I'm going to do. That'll save me time. So it's 1 minus the probability of 9 times and the probability of 10 times. And I'll put them in brackets there like that. So this is a much easier calculation. 1 minus, now the probability of getting 9 heads. So that is heads, which is 0.58 9 times. It's tails, which is 0.42 once. And how many ways can that happen? That can happen 10 choose 1 ways. And then that's also plus then the probability of 10 heads. The probability of 10 heads is just 0.58 to the power of 10. So put that into another set of brackets there like that. And we'll go back to our calculator. So it's 1 minus, open up your bracket, first bracket then, 10, choose 1 times 0.58 to the power of 9 times 0.42, that's just to the power of 1, and plus 0.58 to the power of 10. Don't forget to close your brackets, and equal to 0.9645. We'll take it to 4 decimal places there, which is approximately equal to 96.45%. So what does that mean? That means the probability of landing on heads at most 8 times is 96.45%. Now remember that all of these questions can be taken back to the formula for Bernoulli trials, which is this formula here: n choose or times p to the power of or times q to the power of n minus or, where n is the number of trials, or is the number of successes, p is the probability of success, and q is the probability of failure. I prefer to do these questions without using the formula, and you build up the formula like this. Okay, so thanks for watching that one. If you tune in to the next video, part 3 is questions where you're looking for exactly or experiments. So I have a couple of examples of those ones there. So thanks for watching, and I'll see you in the next one.